This nuclear-powered aircraft carrier measures over 330 meters long, weighs more than 100,000 tons, and carries nearly 90 aircraft. But what most people don't know is how this floating city was engineered and built from scratch. Today, we go inside the world of shipbuilding and massive steel construction to reveal how the USS Abraham Lincoln was made. The USS Abraham Lincoln is not just a warship, it is a floating city powered by nuclear energy, stretching more than 330 meters in length and weighing over 100,000 tons, capable of carrying nearly 90 aircraft and over 3,000 crew members across the world's oceans for decades without refueling. But what most people never see is the unbelievable engineering and construction process that took place years before this giant ever touched water. Inside the Newport News Shipbuilding Yard in Virginia, one of the largest and most advanced shipbuilding facilities in the world, thousands of workers, engineers, cranes, robotic cutters and mountains of steel came together in a perfectly synchronized operation to build one of the most powerful ships ever created by humans. Before construction even began, engineers spent years designing every inch of the carrier using advanced computer modeling, calculating weight distribution, structural strength, reactor placement, aircraft operations, and internal living systems down to the smallest detail. On November 3, 1984, the keel of the ship was laid, marking the official start of construction. This keel acted as the backbone upon which the entire structure would rise. Massive steel plates began arriving at the shipyard daily, each inspected and prepared for cutting. Robotic plasma cutters sliced through thick steel with extreme precision, creating parts that would later become the skeleton of the ship. Sparks filled the air constantly as machines and workers shaped the metal into usable sections. Instead of building the carrier in one single piece, engineers used a modular construction method. Giant blocks, some as large as buildings, were assembled separately across the shipyard. Each block already contained wiring routes, pipe systems, support beams, and internal compartments before being joined with the rest of the ship. This method allowed multiple teams to work at the same time, reducing construction time by years. As these massive modules were completed, giant cranes taller than skyscrapers slowly lifted them and placed them into the dry dock, a huge empty basin where the ship would take shape. Workers used laser alignment tools to ensure each block fit perfectly with the others. Even a misalignment of a few millimeters could cause structural problems later in the ship's life. Welding teams then permanently fused the blocks together, transforming separate steel sections into one continuous structure. Slowly, the hull began to grow longer and taller, looking like a steel city rising from the ground. Inside the hull, thousands of specialists worked simultaneously. Electricians installed kilometers of cables that would power radar systems, communication equipment, lighting, and advanced navigation tools. Engineers prepared compartments for the nuclear reactors, the heart of the carrier that would allow it to operate for decades without traditional fuel. These reactors were installed with extreme caution because they required perfect shielding, cooling systems, and safety measures. Meanwhile, other teams constructed the flight deck, the most recognizable part of an aircraft carrier. This deck had to be strong enough to handle the impact of fighter jets landing at high speeds, while also housing catapult systems capable of launching aircraft into the sky within seconds. Underneath the deck, complex hydraulic, steam, and electrical systems were installed to operate elevators that move aircraft between hangars and the runway above. Massive engines, generators, desalination systems for producing fresh water, kitchens, sleeping quarters, medical facilities, and command centers were all built inside the ship while it was still in dry dock. The carrier was not just a machine, but a complete floating city designed for long deployments at sea. After years of construction, the moment arrived on February 13, 1988, when the dry dock was slowly flooded, and for the first time, the USS Abraham Lincoln touched water and began to float. This was a critical engineering test because it proved that all weight calculations, structural designs, and balance estimations were correct. Engineers closely monitored how the ship behaved in water, checking for stability and stress points. Once floating successfully, the ship was moved to a fitting dock where months of additional work continued. Radar systems were calibrated, navigation controls were tested, safety systems were inspected, and every single component of the ship went through multiple checks. After this, sea trials began. The carrier was taken into open water where its speed, maneuverability, aircraft operations, and reactor performance were tested under real conditions. Only after passing dozens of rigorous tests was the USS Abraham Lincoln officially commissioned into the United States Navy on November 11, 1989. What makes this construction process truly incredible is the level of coordination required. Thousands of workers, hundreds of machines, millions of parts, and years of planning came together to create a structure capable of surviving the harshest ocean conditions while carrying aircraft, weapons, and crew safely across the globe. Every corridor, every weld, every cable inside the carrier represents precision engineering and teamwork on a massive scale. Today, when people see the USS Abraham Lincoln sailing across the ocean or launching fighter jets from its deck, they rarely imagine the giant shipyard, the sparks of welding torches, the roar of cranes lifting steel blocks, and the years of industrial effort that were required to bring this supercarrier to life. It stands not only as a symbol of naval power, but as a masterpiece of modern engineering and industrial construction, built inside one of the largest factories humans have ever created.